right, for number 19, this problem says that you have a triangle XYZ and A is the centroid. So remember, the centroid has medians, and if I have a median, that means that it goes from the middle to the angle. So in this situation, we know that if I have a median, so this section right here, this line is, if this is, let's say this is n, then the other section of it is double that, which is 2n. So basically, in this particular example, they say that they want dz. So they tell us that dz is approximately, or is 12. So I'm going to set up an equation. So let's say that this is n and this is 2n. So I know that n plus 2n equals 12. Well, if I combine like terms, that gives me 3n equals 12. So therefore, n equals 4. Well, they want us to find the distance from D to A. So D to A, or A to D, is going to be 4. And then the distance from Z to A, or A to Z, is going to be 2 times that, which is going to be 8. All right, so for number 20 says that TR is the diameter of circle O, and it has a length of 16. So for this distance right here, we know that T to R is the diameter. Now, they want to know what is the approximate area of the sector that is bound by POR. So we're looking for the angle POR. So I'm looking for P, O, and R. So they want to find this arc, this area right here. So with that being said, I see that my angles are in degrees. So we're going to use the degree formula. So remember, that's theta divided by 360 times pi r squared. So we're doing pi r squared because we're doing area. So if I add up my two angles that create that area of that angle, we're looking at 125. So this is going to be 125 over 360 times pi r, not r. If we know this is 16, then that's going to have a radius of 8. So that's going to be 8 squared. All right, so let's pull in Desmos so we can put that in. So we have 125 divided by 360 times, and we're going to do pi times 8 squared. And I got approximately 69.8. So 69.8 would round up to 70, making the correct answer A. All right, so let's look. So you should have already done 21. 21 you would do in Desmos. You would look for your center, and if you plug that into Desmos and you check, the correct answer here is B. So if we check that, we can see that we have y minus 3 equals 25. If you like doing it with the minor arcs and 1 and 1, you can do that as well. Because my iPad is zoomed out, it's not going to actually, there we go. So this one does have a center at -2, 3. And I do have a radius of 5 units. So the correct answer here is B. All right, for 22, it says Jessica created a model of an ice cream cone by combining the shapes of a cone and a hemisphere, which is half a circle, or half of a sphere. So using the dimensions of the model, what is the volume of this? So there's two things that we're going to have to do here. We're going to have the volume of a cone, and we're going to have to find the volume of the sphere, and then we're going to take the volume of the sphere and we're going to divide that in half because we only have half of one. So remember, the volume of a cone is 1/3 my base times my height. The sphere is 4/3 pi r cubed. So the first thing I'm going to do is I'm going to find the area of my base here, which my base is a circle. so I can find that I'm going to find the area of a circle, which is pi r squared. So my radius is 3, so I have pi 3 squared. And for right now, I'm just going to leave it in terms of pi because I see my answer choices are in terms of pi. So this is 9 pi. Now I'm going to find the actual volume, which is 4/3 times 9 pi times my height, and my height here is 10. So I'm only going to multiply my numbers in this particular problem. So we have 1/3, 9, and 10. So I can just plug that into Desmos. So I have 1/3 times 9 times 10, and that gives me a volume of 30 pi. All right, now I'm going to do the volume of my sphere. So I have 4/3, and that's going to be pi, and my radius is still going to be 3, but that's going to be cubed. So again, I'm going to do 4/3 and the 3's cubed. And that's going to give me 36. And I have 36 pi here. Now, I need to divide that in half, because if I divide it in half, that gives me half of the sphere. And I only want half of the spheres because that's all I have for the ice cream cone. I don't have a whole sphere. So when I divide that, my volume is going to be 18 pi. And then, of course, I'm going to add those two together to make the whole thing. So that's going to give me 30 pi plus 18 pi is going to be 48 pi. So my correct answer is A. All right, so for 23, I have a cylindrical tank that holds 289,000 gallons of water, and it is 23 feet deep. What is the approximate diameter of the tank? All right, so first thing I need to I like to draw my little cylinder, and I know that the height, or because it's 23 feet deep, that's 23 feet. Now, one thing we need to pay attention to is the fact that it told us that 1 cubic foot is 7.5 gallons. So what we're going to do is we're going to find the volume of the actual tank. And once we find that we can find the volume by taking the gallons of water. So we know that the gallons of water here are 289,000 gallons. So if I divide that by 7.5 gallons, that's going to give me 1 cubic foot. And 1 cubic foot is 1 cubic foot of volume. So I'm going to find the volume by saying the 289,000, and I'm going to divide that by 7.5. And in doing that, that's going to give me the volume. And I need to find the volume so that I can find the diameter. And I can find the diameter by finding the radius. So this is going to be approximately 38,533.3. So we're going to take our volume formula. So remember, the volume for a cylinder is base times height. Well, I have a circle as my base. So my base here is going to be pi r squared. So I know that my volume, so I'm going to kind of color code here. I know my volume is going to go here. And I know that my height, so my height in this particular problem, let me get another color. So my height is 23, that's going to go here. And what I'm going to do is I'm going to plug that all in, and I'm going to solve for r. So I'm going to solve for r, and then once I solve for r, I can find my diameter. So I have 38,533.3, and that's going to equal pi r squared times my height, which is 23. Now, remember, we're trying to solve for the actual radius. So everything here that's not with the radius, I can go ahead and divide over. So I can divide 23 and pi on both sides. And by doing that, that's going to give me r squared left. So if I divide that and I do 38,533.3 and divide it by 23 pi, I get 533 point, we'll say 3, and that equals r squared. Now remember, if we want to solve for r, we're going to take the square root. So I'm going to take the square root of 533.3, and I get that r is approximately 23.1. But the question doesn't want just r. The question wants the diameter. It doesn't want the radius. So I'm going to multiply that by 2. So if we multiply that by 2, we got 46.2, so approximately 46. All right, so for 24, that should have already been done. So for 24, you would have done this in Desmos, and you would have matched the graphs. And you should have got that the answer was A. All right, so for number 25, so it says, suppose we have this polynomial. Now, the key to this polynomial is we're missing the constant, which they labeled as K. It says the remainder of the division, if we divide it by x plus 1, is negative 8. What is the remainder of the division if they divide it by x minus 1? So this is a two-step. The first thing we got to do is figure out what K is. Once we can figure out K, then we divide it by this polynomial. So what I'm going to do is I'm going to set up synthetic division. And I'm going to set up synthetic division so that I can use what they've given me. So I have positive 1, and we're going to use negative 1 because it's always the opposite. And we know the remainder is 8, so I don't need any placeholders. So I'm going to pull my constants, and I'm going to put the K there. And I know my remainder is negative 8. So I'm going to go through, and I'm going to do negative 1 times 1 is going to be negative 1. Add that, get negative 3. Negative 1 times negative 3 is positive 3. That's going to give me 16. Negative 1 plus 16, or negative 1 times 16 is negative 16. So the question is what does K have to equal in order to add negative 16 and get negative 8? Well, K would have to equal 8. So now that we know that, we found K, we can do synthetic division again, but now we're going to divide it by x minus 1. So if I divide it by x minus 1, we're going to do the opposite, so it's positive 1, and we're going to do 1, negative 2, 13, but now we know K is positive 8. So they want the remainder, so we're going to pull 1 down, multiply that by 1, add that, get negative 1. 1 times negative 1 is negative 1, add that, get 12. 1 times 12 is 12, add those, and you get a remainder of 20. All right, so number 26, you should have already gotten this answer as well based off of what I asked you to do in class. The answer was D. So remember, you take the left side, you do y equals that. You do the right side, do y equals that, and you find the intersection. And you can do that with any equation. If it's an equation and it has an equal sign, you can do that with any problem. All right, number 27. It says Samantha invested $10,000 in 2 different financial plans in 2013. The predicted value of the plan is modeled below. So we have Plan M. Plan M has a rate of 7.5% compounded continuously. So if you remember, compounded continuously is y equals PERT. So I know this is y equals, my initial value is 10,000. E, we're going to change this to 0.075. And T. Now, they give you that Plan N, so we have Plan N as well. It is given to you by a polynomial, and X is the number of years after 2013. So, they want to know, when is Plan N greater than the predicted value of Plan M? So we got to figure out when is that greater. So I recommend using Desmos here and look at the graph. So you would put in both equations. So we have 10,000 E raised to 0.075x. Then we have y equals And then we're going to put in the polynomial given. Now, here's the deal. So if we're looking at this situation, if you notice that the initial value is 10,000, so you would need to adjust your graph. So we would need to go to the y-axis, and if we're looking at 10,000, let's give ourselves a little wiggle room and do 15,000. So if I do 10,000, here's what you're going to barely just kind of see it. Now, if you want to do that and then adjust it, you can definitely do that. So the question is when was plan N greater than plan N? So remember, plan N for ours is in black. So when is it greater? So along the graph here, so purple right here in this area is still above it. So that's not greater. So we're going to keep going. We're trying to look for when the purple goes below. So the purple goes below after 28 years. So that's a key thing. So it starts at 28 years. It's still above, still above, still above, still above, still above, still above. So our plan N is still above in this situation. So it stays above it. So the question is 28 years, when did it actually go above it? Well, if we started in 2013, then we're going to add 28 years to that. Okay, so 8 plus 3, that's going to give me 11, and that's going to be 4. So 2041. Well, obviously, give or take a year because it's approximate. So we would say it started in 2042. So in 2042, that's when it began. Now, this says that it stopped in 2073. So I'm going to just kind of check that out, and I'm going to subtract the original year. So we're looking at 60. So if we're looking at 60 years, so if that would be like me zooming completely out and going to look at, we're getting close over here. So 60 years is this line. If you look down at the very bottom, you can see 60. And we're getting close. We're not, there it is. So 60 years later, that's exactly what the problem says. So it's just a matter of you manipulating the graph a little bit. All right, so for number 28 says the system of equation is shown below. What is the distance? So distance means that we're going to subtract our two values. Or we may have to find the distance using the Pythagorean Theorem. So those are the two options that we can go with. It just kind of depends on what the problem looks like. Of the 2 points of intersection. Now, I'm probably going to guess that we're going to have to do Pythagorean Theorem, because if we're looking at the intersections are going to be diagonal from each other. So x minus 3. And then we have y equals 1/2 x. All right, so we have our first point at 1, 2, and our second point is at 6, 3. So I'm just going to kind of draw a general graph here. So we have 1, 2 is our first point of intersection, and then we have 6 and 3. So they want to know what is the distance between those two. So yes, we are going to have to do Pythagorean Theorem here. So if I do Pythagorean Theorem, remember you can make your right triangle your L. And when you do that, that's going to help you find your A and your B value. So that's going to be a unit of 1. All right, so I just realized that I graphed this wrong because the first point was at 2 and 1. So that's 2, 1. And then the other point is at 6, 3. So we want to find the distance here. All right, so we're going to redraw that and do our L shape and get our right triangle. So we have a distance of 2 and a distance of 4. So we're doing a Pythagorean Theorem for 2 and 4. So we're going to do 2 squared plus 4 squared, and that's going to help us find c squared. So 2 squared is 4 plus 4 squared is 16, so that's 20. So c squared, we take the square root, and my distance is the square root of 20. All right, number 29 says Fred drives an average of 15,000 miles per year, and his car gets 20 miles per gallon of gas. The average cost is $3.25 per gallon. He buys a new car. In his new car, Fred continues to drive an average of 15,000 per year, and the average cost of gasoline remains the same. Approximately how many more miles per gallon does the new car get if Fred has a savings of $650? So the first thing we need to do is we need to analyze the old car. So if we analyze the old car, we know that he drives 15,000 miles per year. And out of those 15,000 miles, he gets an average of 20 miles per gallon. So we're trying to find the gallons that he uses per year. So if I divide that, so if I do 15,000 divided by 20, that's going to give me 750 gallons that he uses per year. So if he uses 750 gallons per year, then we want to know how much he's actually spending. So he's spending, if I multiply it by the price per gallon, he's getting, so we're going to multiply it by 3.25. So he's spending around $2,437.50 per year. Now, the key to this problem is it says that he has a savings of $650 per year. So now we're going to talk about the new car. So with the new car, we're going to subtract that $650, and we're going to figure out how much he's actually spending per year. And he's spending with the new car $1,787.50. And now we're going to work backwards. So we're going to divide the $17,807.50. We're going to divide that by 325. And if we divide that, that's going to give me how many gallons he's using in his new car. So he's using 550 gallons. Well, if he's using 550 gallons, then we need to figure out how many miles he's actually, how many miles per gallon he's getting. All right, so we know he's getting 550 gallons in his new car. That's how many gallons he's using per year. So he's still going the same amount. So we know he's going 5,000 miles. So we're going to divide that by the gallons, and that's going to give me how many miles per gallon he's able to get. So we're going to do 15,000 divided by 550, and we know he's getting 27.3 miles per gallon. Well, the question is, how many more miles per gallon does he get in his new car? Well, he gets 27.3 in his new car, minus the original 20, so he's able to get about 7.3 more miles per gallon. All right, number 30. So a student wants to determine the most liked professor in her college. Which type of study would be the most practical to obtain this information? So if I do a simulation means you model something and you see it in real life and you mimic that. Well, if you're trying to figure out who's most liked, you can't really do a simulation, so that's out. An experiment means you actually experiment whether how can you determine if they're liked or not by doing an experiment, because everything could potentially be different in that experiment. So then we have a survey and we have an observation. Well, you could observe the students with the professor and see who likes the professor, but who's to say that if you pick a class, that one class likes their professor over another? So a survey is the most practical because you can survey a multitude of people, and on top of that, you can get a variety of people. All right, number 31. It says a principal wants to survey 150 students to determine which electives to offer during the next school year. There are 1,800 students in the school system, or in the school. Which procedure could the principal use to select a sample using a systematic random sample? So random sample means that anybody has the same probability of being picked. So we still want that same thing. We still want the same probability of people being picked, but a systematic means that you have some type of procedure to pick them. So it's not just I'm going to put every 100,800 students in a hat and pull their names. This is more systematic where it's a little bit easier. So the first one says, obtain a list of all students. Start with the 8th student and then select every 12th student until 150 have been selected. Then the next one says, select the first 150 students who enter the school. Choose the 5th student to come into the cafeteria and then select every 3rd student who comes into the cafeteria until 150 have been chosen. Place students' names on a slip of paper and select 150 slips. So D is definitely random, but I would not consider that systematic. Systematic means that there is an actual system, there is a procedure. So if you just put slips of paper in there, that's not going to be systematic. So D's out. Now, for C, choose the 5th student to come into the every 5th student to come in the cafeteria, and then select every 3rd student who comes in the cafeteria until 150 have been selected. Well, that is systematic where you would select every 3rd. However, it is not at random because you're only choosing people that go to the cafeteria. Not everybody goes to the cafeteria, so not everybody in the school as a student has the opportunity to be selected. So that's not random. B says select the first 150 students who enter the school. So again, that's not systematic, and I wouldn't consider that necessarily. It kind of is random, but everybody doesn't have the likelihood of being selected because you're talking about the first 150 students in the school that may be a select pocket of kids versus others. So A says select a list of all students. So there's the key. All students means that everybody has the same likelihood of being selected. So we select the 8th student and then select every 12th student until 150 have been selected. So not only is that random, but it's systematic. So the answer is A. So for number 32, you should have already done this problem. The answer was D. You can look at this in Desmos, or you can look at or just know your rules. So this one says we're going down 2, so we're going to subtract 2 from the back so that we can get rid of A and C. And then we're going to go to the right 3. So remember, when you're in the function, it's the opposite. So instead of being plus, it's going to be minus. If you decide to look at it in Desmos, you can look at the original. So we can look at x to the 3rd. Y equals x to the 3rd. And then you could check every answer. So if I do the first one, I would have x plus 3 cubed, and then we're going to do plus 2. So if I'm looking at, let me move this over. If I'm looking at my pieces, I can see I start at 0, 0, and I'm going to, so this point right here is at negative 3 and 2. So this one went to the left and up 2. So that's not going to work. So you could check every single one until you see that D goes to down 2 and right 3. All right, so our next question, again, we already talked about that one. The answer to that one was C. So to be an inverse, remember, it's a reflection over the line y equals x. And you would see that if you plug that original one in, if we have y equals 1.5 raised to x plus 4, and because it's an inverse, it's symmetric over that line. And then if we put this one in, so we have log of x, and then we're going to subtract 4, and then on the, oops, that is not correct. That's on the outside of the parentheses, so let's redo that. And then we have log of 1.5. You can see that that is symmetric. You can even check a point if you want to. You could check the 0, 5 and 5, 0 because they should flip with each other. All right, number 34, it says the volume of a rectangular prism. So remember, a rectangular prism is one that has a base of a rectangle on both sides, and then the prism, and again, y'all know that I'm not the best drawer, has the faces, the four faces on the outside. So it says the volume is this. So that's the key. We have this volume and the length is that. Now, the next key is that the height and the width are equal. So what is the width of the prism? Well, what we can do here is we can divide, because if we want to find the width, that means we would have to divide and get rid of the length, and then we're left with the width and the height. Well, because these are polynomials, I can do synthetic division here. And if I do synthetic division and I divide the length, then I'm left with the height and the width. So we do not need any placeholders. And I'm going to do synthetic division here. Positive 6. So that's going to be 1. 1 times 6 is 6. Add that, get 4. 6 times 4 is 24. Add that, get 4. And then 6 times 4 is 24, and get a remainder of 0, which should happen. So that means that I'm left with x squared plus 4x plus 4. So how do I divide this in half? Well, I would need to factor. And that's going to give me the two binomials that I'm looking for. So I need two numbers that multiply to give me 4, but add to give me 4, which is going to be 2 and 2. So this is x plus 2 and x plus 2. So this would be my height and my width, which means that my answer is A. All right, for number 35, we have a piecewise function. They want us to find f of negative 3, 2 times f of negative 1, and then minus f of 4. So for the first one, I have f of negative 3. Well, f of negative 3 is equal here, so we're going to be plugging it into this one because it's equal. All right, so I'm going to plug that into Desmos, and I get negative 3. And I'm going to square that, and we're going to do 2 plus negative 3. And this gives me negative 15. All right, for the next one, I have negative 1. Well, negative 1 falls in between that area, so we're going to plug it into that one. So we have 2 times 1/3. And we're going to raise that to 2 times negative 1. And we get 18. Now, this needs to be 2 times 18, so that's going to be 36. And then for the last one, we have positive 4. Well, this one is equal to 4, so we're going to plug it into that one. Now, it may not always happen where you plug it into every one. You need to check the domain that's given. So we have 2 times 4 minus 5. And then we have 4 minus 7. And that's going to give me minus negative 1. And then I just figure out the whole thing. So we have negative 15 plus 36 minus negative 1. And I got 22. All right, for number 36, so it says which function goes to positive infinity most quickly as x increases. So most quickly means which one is the steepest. So which one is going to have the steepest change on the right side? Why the right side? Because it's when x is increases. So for these, I'm going to want to put these into Desmos, and I'm going to compare all of my graphs. So I have log of x. I have e, and that's being raised to x minus 9 minus 3. Then I have y equals x squared plus 5x plus 6. And the last one. So 3x to the 5th power plus 4x to the 3rd minus 11x minus 6. So there's a lot going on here. So let's kind of look at our graphs. So I can see that the black one definitely is not going to be, so the black one is the E one. Why is that not going to work? Because all of these other ones on the left are going up much quicker than this black one on the right. So we're getting to the Y values a lot quicker with the other ones. So I can also see in the red one's taking a lot longer to get there than the blue and the purple. So the red was the polynomial. So then last, so we're basically comparing the blue and the purple. So the purple is the logarithm. So obviously the logarithm is very close to that line. So it's going up y much more quickly than the blue is. So the answer to this one is A, because the purple one is the steepest out of all of them on the left side or on the right side. All right, so for number 37, you should have already done this one. Remember, we have an equation, so we're going to set them equal to y, and you should have got your answer is A. So if we look at those, I have y equals 9 raised to, and there we have negative 3x plus 2, and then y equals 48. So in this situation, we're definitely going to have to get up to 48 and then zoom in. You can zoom in however you feel like you need to do it, but click it, and it's always the x value. Same thing with this solution. I would have set this equal to y, this equal to y. Now the key to this one is it would have given you a decimal, and you would have had to check all of your answer choices to figure out that your x value was 2.8, and your answer should have been D. All right, for 39, we already you already should have done 39. So for 39, you would have put this into Desmos, and you would have matched your graph. The only thing you've got to be careful here is when you put this in Desmos, it's not going to be formatted exactly the same way. So we have x plus 7, and then we have x squared plus 4x minus 21. And then divide that. You see how it does a division of the whole thing again, and hit the division again so you can get that whole fraction divided by. Then x squared plus 8x plus 15. And there's my graph, and the correct answer for this one was A. So once you checked your answers here, when you plug these in, you're going to see which one matches, and I can see that my blue overtook my red, so that's the reason it matches. So the next one says, which function does not have a set of all real numbers in the domain? So all real numbers means negative infinity to infinity. Now, when I look at this, I'm going to be looking at which ones have either a denominator, because remember, denominators cannot be equal to 0, or a square root. So the one that has a denominator is B. Those are the only two things that can happen to cause it to not have a domain of all real numbers. All right, so for number 41, again, you're going to put that in Desmos, and you're going to match the graph. The only thing I will say is be careful. If you look, these have negative exponents. That's okay. You just plug them in the same way you would any other exponent. And your correct answer would have been D. Now, number 43 we've done before, but I did want to hit it real quick just to make sure that we remembered how to do it, because this is a type of problem I cannot match in Desmos unless I plan on guessing and checking at all of the pieces. But basically, where it's an addition problem, and in order to do addition, we have to have a common denominator. So right now, I need my denominator to have an LCD of x plus 4 times 7x minus 2. Okay, so that means that on this side, we're going to multiply this side by 7x that should be minus 2 over 7x minus 2. And then on this side, we're going to multiply this side by 4x plus 3 over 4x plus 3. All right, so first thing I need to do is multiply that. If you need to use your box method to multiply, please do. If you don't, then no worries. Just multiply it like you normally would. So in this situation, I'm going to get 21x squared, negative 6x. This is going to be negative 35x and positive 10. And then I'm going to combine my like terms. So on this side, I have 21x squared. And then I combine my like terms to make negative 41x plus 10. And that's all over 7x minus 2 times 4x plus 3. That's the first side. So now on the other side, I'm going to do another box because I need to multiply the other top pieces. So I need to multiply negative 2x and 1 and 4x plus 3. So negative 2x and 1 and then 4x and 3. So that's going to give me negative 8x squared, 4x, negative 6x, and positive 3. And combine my like terms. So for this one, we're going to be adding. So we have negative 8x squared, negative 2x plus 3. And that's all over 7x minus 2, and then 4x plus 3. And now, all I have to do is combine my like terms for the numerator. So I have 21x squared and negative 8x squared. So that's going to give me, so what do we have? 21 minus 8. So that's technically taking away 1. So 13x squared. All right, then we're going to have negative 41x and negative 2x. So that's going to give me negative 43x. And then finally, we have 10 and 3, which is going to give me 13. So that's going to give me that A value, that B value, and that C value. So A is 13, B is negative 43, and C is 13. All right, so I hope this helps. If you need or have any questions, just email me and let me know what I can do to help you.